Keysen Markley, doing some TLC plate phosphorescent type stuff.
Oh.
Alright, so first you want to mark your TLC plate. You want to do this on the dull side, not the shiny side, because you don't want to mess with your results. You want to make your first initial line roughly about a centimeter from the bottom. Draw that as straight as you can. And try not to chip it like I just did. And then you want to make two small lines here to mark where you're going to be spotting it. Alright, and to be able to develop your TLC plate, you need a developing chamber. To start with, you just need a basic little glass jar here. You want to put a filter paper in and try and get it as close to the walls as you can. Then for your solution, you're going to use 2 milliliters of ethyl acetate mixed with 8 milliliters of heptane. You want to get that all in there. You want to close the lid so it can't evaporate out. You want to move it over just a little bit so the filter paper is nice and wet, which will keep it from evaporating again later when you have the actual thing in there. And then next for your TLC plate, you're going to need your samples that you're going to be testing. So 2 samples we'll be using are fluorine and fluorinone. Gather these samples using a little homemade capillary tube from melted glass. So what you need to do is you need to hopefully not break these things. Open your lovely sample here. Take your capillary tube and you want to just kind of gently rest in there. You don't want to stab it and break it. It should gather up just a little bit. And there you want to gently tap it onto your sample. You want to get as little as possible, generally between 1 to 2 millimeters. Blot it there on there. I think mine's about a millimeter-ish roughly. Relatively quickly so nothing evaporates off of it. Second, you need the fluorinone. Do the same procedure with that one.
Brandon, how long do you guys let your thing dry before you use it?
So in that case, that one was a little big, but not too horribly so. And you'll just dispose the 2 pieces. You don't want cross-contaminated. And from there, dry first, or we do actually. And once you have those 2 samples, you want to take it, very gently put it in the thing if you can. In my case, it's going to be interesting to get it in there. You want to keep it, hopefully, from doing what it just did. You want to try and get the solvents or the samples towards your filter paper so they get the best contact possible. So your shiny side will be away from the filter paper. Mine's a little close, but that's okay. And you want to close her back up so nothing evaporates again.
I did 60 minutes last time. I knew I did real bad.
Go.
So once you've had it in there for a fairly sufficient amount of time, you want to reach in there and check on it, hopefully without it falling over. When you do that, you want to check and see if, to make sure it's filled up about, roughly about 80% of the paper there. So once you've done that, you want to take it, set it out to dry. You want to put that on a lovely piece of paper so it doesn't harm anything. And then you want to let it sit and dry for a little bit, which should happen fairly quickly as these are liquids at room temperature. You also want to make sure to put on your solvent line, which is marking how far the solvent traveled up the paper. And try and do that also lightly and carefully, trying not to actually touch the solvent or mar the paper too badly. And that's for measuring your, can be used later for measuring the solvent as well. Once you have your solvent nice and lovingly dried, you want to go find yourself a UV lamp. Here, lovely little UV lamp. You want to keep it nice and dark so you can actually see what you're about ready here. You can go and lift her up and place her into here. As you can see, it's caused two significantly different dots. So you wanna, you can go and move the camera up here towards the top here so you can see from there. Want to look through the top here to get as accurate of a picture as you can. You want to circle on your plate the two different dots. You want to be as gentle as you can, but still get an accurate depiction here. Once you have that, you can pull her back out. So once you have it out of your UV lamp, you want to measure your distances between your initial solvent line to the solvent front line, which is how far the solvent traveled up the paper, and also from your initial sample spots to the center of your new sample spots. Now you want to use these in millimeters just to keep your calculations simple. Now from the one line, from the first line to your solvent front, in this case, it's going to be roughly 3.8 centimeters or 38 millimeters. And then from your first sample, which you want to do from the center, it's going to be roughly about 22 milliliters or 22.2 centimeters. And then from sample 3, starting from there, you're going to have about 13 milliliters, or millimeters. And then whenever you're doing your calculations for your RS values, you're going to take the value you found for the distance here, you're going to divide it by the value for here, and then you're going to do the same for those. And your value should roughly fall somewhere between 0.2 and 0.8. Alright, now once you have those calculations, bring it on over here, and you want to do some fanciful stuff here. You can zoom in the knot however you want. You want to make sure to mark down what your solvent front line was, or also known as the distance from the two lines, how far your sample 1 was from that line, and how far your sample 2 was from that line. Now when calculating RF, of the first solvent, you want to take its distance divided by the distance the solvent front traveled, and you'll get your answer. Now note, RF has no units, because when you divide, both the millimeters will cancel out. And you want to do the same thing for the solvent 2. So for solvent 1, 22 divided by 38 was about 0.58. And then for RF of solvent 2, it's 13 divided by the 38, which is about 0.34. And then both of these are between 0.2 and 0.8 range. That tends to be optimum for TLC. And that's how you do a TLC solvent.